Okay, so I want to look at the radius and interval convergence for power series. This is most centered in sheet 2, that is question 15, the whole lot of it. So the first part, A, I think before I do any part, we want to use a ratio test. Okay, which we know that it said if you find the limit as n goes to infinity of the absolute value of an plus 1 over an, if the series converges, then we require this limit to be less than 1. And so that's what we're going to do. So we find the limit. After we find the limit, then we check if that limit can be restricted to 1. And then we also check where or how to bring in the interval convergence. Okay. So now we want, when we find it, for the radius, the formula is x minus, let me say x naught, less than radius. So this will be the radius. So you have to express it in this form for you to get the radius. And then the interval. So this is the radius. So this r is the radius. Then now the interval, you say minus r less than x minus x naught less than r. So now we can have x naught minus r less than x less than r plus x naught. That would be the interval convergence. This one. Okay, so we have to be careful on how we find that. But then, if suppose you've made a mistake or you've forgotten how to get the radius, you forget this part, you could as well get the interval, and then if we want to get the distance, so we can subtract r plus x naught minus x naught minus r. So we are going to have r plus x naught minus x naught plus r. So this is giving us 2r, and then we could divide it by 2, and then we get r, which is the radius. So you can as well get the length of the interval and then break it by 2 to give you the radius. It's still the same thing. So that's it. Let's go to the first one. A, we get the limit as n goes to infinity of the absolute of an, that is 4 to the power n plus 1 over n plus 1 squared. And then we divide it by 4x power n over n squared. So this is going to be the limit as n goes to infinity. So we can say that if we reciprocate this, we use multiplication, then we are going to have the absolute of 4x to the power n multiplied by 4x over n plus 1 squared multiplied by n squared over 4x to the power n, like that. And then this one now cancels with that one. So we're going to remain with the limit as n goes to infinity. We can separate, we write the 4x alone, and then we get the limit. Now we can even remove this from the absolute, n squared over n plus 1 squared. Okay, and so the limit here, we can see that this is just 1. So we have the absolute value of x. Now we want this absolute to be what? The ratio test says this can only converge if this is less than 1. Now we need to express it in that form. So we are saying the absolute value of x then should be less than 1 over 4. So the radius is 1 over 4. When you just reach here, this is your radius. And so the interval of convergence now, interval of convergence That's the one we get. Oh, negative 1 over 4 less than x less than positive 1 over 4. Then you can as well check if the boundaries are restricted or not. If you substitute a negative half in the question there, you will notice that what you are getting is actually an alternating series which converges. You also pick a 1 over 4 inside, you are going to get a 1 over n squared, which is a p series. It's also convergent. So it means that our interval of convergence is going to be from negative 1 over 4 inclusive all the way up to 1 over 4. So we have found the two things that we needed. The first one is the radius. The second one is the interval of convergence. Like that. Okay, that is for A. We go to B. B is the sum as n runs from 1 to infinity of negative 1 to the power n 2x minus 3 to the power n over n multiplied by 2 to the power n. Again, we bring in the ratio test, so the limit as n goes to infinity, the absolute value of an, that is negative 1, n plus 1, 2x minus 3, n plus 1 over n plus 1 and 2 n plus 1. Then we divide by negative 1 and 2x minus 3 n over n 2 to the power n. Like that. And what we get, so we have the limit as n goes to infinity. The negatives in the absolute, they lose, they go, and then we remain with 2x minus 3. So now I'm expanding the n plus 1. This will be n multiplied by 2x minus 3 over n plus 1, 2 to the power n multiplied by 2, and then we multiply by n, 2 to the power n over 2x minus 3 to the power n, like that. So we have this and that canceling, this and that canceling. And so we remain with the limit as n goes to infinity, the absolute of 2x minus 3, okay, and n over 2n plus 1. So again, this one does not need to be in the absolute because n runs from 1 to infinity, so it cannot have a negative there. And then we get the limit there, what we have is just the absolute value of 2x minus 3 over 2, because n over n there, we're just going to give us a 1 as the limit inside. So remains the half there. So this 2 is coming from inside there as we get the limit. So now we are saying by the ratio test, this absolute of 2x minus 3 over 2 should be less than 1, meaning 2x minus 3 should be less than 2. We want to find the radius. So to find the radius, we must factor out the inside. We factor out a 2. We want it to be in this form. So we get that less than 2. So we want it to be in which form? In the required form. So the 2 comes out, and then we have x minus that less than 2. So we divide by 2, we divide by 2. So we eventually get x minus 3 over 2 less than 1. So 1 is the radius. So the radius is equal to 1. And the interval now, the interval you can distribute now, you say, okay, negative 1 less than x minus 3 over 2 less than 1, and push a 3 over 2 this side minus 1, that is half, less than x less than 3 over 2 plus 1, that's 5 over 2, like that. Okay. So again, let's see what would happen if you had missed, if you could not reach here and you went to as far as the interval and you want to get the radius. If you subtract that to get the distance, you have 5 over 2 minus 1 over 2. That is 4 over 2, which is 2. And then you divide it by 2, it will give you 1, which is the radius. So either way, you can have the radius. Then the interval. Then now, the job is to check if we pick half and take it where there is x, we are going to have a series of what kind? So it will be 1 minus 3, that is negative 2 to the power n. And then the negative can be out to the power n, joins the other one, so that you have negative 1 to the power n plus 1. And then you have a 2 to the power n over 2 to the power n down. That gives us a diverging series because we're going to have the n in the denominator. So it means that the half is not included because then it's going to diverge. So the interval of convergence, what about the 5 over 2? 5 over 2 there, we're going to have 5 minus that which is 2, again 2 to the power n, over 2 to the power n. So it means that I'm going to, under convergence again, that one becomes a diverging series because it takes the nature of the harmonic. So it means that the interval here is 1 over 2, 5 over 2. Okay? So again, the interval of convergence, the radius. We go to C. C has n equal to 1 to infinity, negative 1 to the power n plus 1, and then x minus c to the power n over n c to the power n. So this is like a general case of a B. So now it looks like that negative 1 has already come out. That's why it is negative 1 to the power n plus 1 there. The one that we are saying it come out from the previous one. The ratio test again, the limit as n goes to infinity, absolute. So I'll leave out the negative 1 because I know if I take it inside, it will be eaten up by the absolute. So I'm going to have x minus c. So as I write the n plus 1, I'll be careful. I'll write it as n, and then the plus 1, I'll write it alone. And then over again, n plus 1. I'll do the same, cn multiplied by c. And then now I'll multiply as I push this in the numerator, and then in the denominator like that. And then cancel, this one cancels with that one. And then this one cancels with that one. So what do we remain with? We remain with the limit. The other part is going to be n over n plus 1, that is 1. And then I remain with the absolute value of x minus c over c less than 1. So again, I need to remove that c there. So we're going to have absolute value of x minus c less than c, because c is coming out of the absolute as a positive value. So you can cross multiply and still fix the inequality. Remember, we don't know the value of c, so it could be negative. But the fact that it's in the absolute, then we are sure that it comes out as a positive value. And so now, just here, we are saying the radius is equal to c. And the interval now is equal to x minus c less than c, and this side negative c. So that we get a 0 less than x, which is less than 2c. Either way, you could add and still get the radius to be c. And to subtract, get distance, and subtract, and so don't get the radius to be c there. That's a good one. Okay, so we go to D, the final thing now on this question. D, n is equal to 1 to infinity, and then you have n factorial, x minus a to the power n, provided a is a real number. Or even see there on the real number, so that's okay. So now here again, you get the ratio test, the limit as n. You know, the ratio test works very perfect for factorial numbers. So we have n plus 1 factorial, and then x minus a n multiplied by x minus a over n factorial x minus a to the power n. So again, you can see this and this cancels. So we remain with the limit as n goes to infinity of what? Of n plus 1 multiplied by n factorial and then x minus a that over n factorial. So this and that goes. So then what we get? So we get the limit as n goes to infinity, n plus 1 and then absolute of x minus a, like that. So now here, when you get the limit, it comes out to be infinite. So we have to be careful, okay? The limit comes out to be infinite. So now, what is going to be the radius? Because it means that this guy will converge not for all values of x, but not for all x real. Yeah, this converges at not necessarily an interval because this one blows to infinity. That's the limit there that we have. The limit blows to infinity. So the only time we have convergence here is when x is actually equal to a. And at that point, the radius is 0. Okay. The other point is, well, if you restrict x to whatever values, but n blows to infinity. This part blows to infinity. So it's either we have convergence when the radius is 0. So then the interval there is going to be, the interval there is going to be bounded a less than x less than a. Okay, for radius to be 0 to just get a point. Or else it diverges for x. So we have that because of the point thing. This one has failed to converge without limiting the n. It requires us to talk about the n before we talk about the interval. There's one thing that we should be careful about also. So just check. So this one only has a point convergence, but the radius is 1, and the interval is a less than x, which is less than, meaning that a less than x, which is less than. Which is less than. So the one to write. So here I want to write x minus a. Suppose that if I restrict it to be less than the radius, which I've said is 0 now, so it means that we're going to have x minus a less than 0. So x will be less than a. So in an interval form, then the other side you have, you cannot necessarily have an interval because of this, which doesn't have a. It cannot be less than 0. So it just fails to be restricted except at a point. I hope you understand here. So here what you're saying is that because this guy is close to infinite, the limit there comes out to be infinite times x minus a. So unless x is equal to a, so that we get 0, then there will be no convergence. Because if we get 0, then maybe because 0 is less than 1, so we're okay, we can talk about convergence. But if if you allow infinite, which is greater than, because infinite is greater than 0, that means that this thing is going to diverge for those values of x. So the only time we can have that is when this guy restricts itself to only a 0 as a radius. And now you're wondering how you can get an interval if the radius is 0. There's no interval there. So you're only talking about x being equal to a. If you want to talk about the interval, it's only at a point, not space. Okay.